Hi folks, and welcome back to Physics with Captain Rod. I'm making this video here to introduce for you the concept of centripetal acceleration. So for starters, let me write this over here. So acceleration is a vector quantity, and it's equal to change in velocity over change in time. This would give you what's called your average acceleration over a time interval. And again, remember that velocity itself is a vector, which means it has a magnitude and a direction. So if you change either one, the magnitude of your velocity or the direction, you are accelerating. So if we take a look at this picture, this is supposed to represent, maybe a rock on a string or something like that that's moving around in a horizontal circle, maybe on a tabletop or something like that. And for this picture, don't worry about any other forces other than the force applied by the string onto the rock. So if I were to draw a free body of the rock at this location, it would look something like this, right? The string would be pulling inward. Now notice that that force points along the string towards this location, which is the center of curvature of the circular path. So this force is the force that's causing the velocity to change direction. Now, if you pay attention to these two pictures, this one and this one, and we look at the velocity change, it looks something like this. In this picture here, right, we have an initial velocity vector, we have a final velocity vector, and then here is the change in velocity. Now vectors follow a similar type of math in that whatever you start out with plus whatever your change is equals your new amount. This is true for any quantity, vector or not. So this vector starts something like this. I don't have that perfectly parallel, but humor me for the picture. It ends something like this. Therefore, the change is this animal right here. And again, notice that vectorially, your initial velocity vector plus your change in velocity equals your final velocity or your new velocity. And again, the really key concept here is that the change in velocity points this way, parallel to the tension, which is towards the center of curvature. And then if you take that change in velocity and you divide by time, you get a quantity, if you run through a little bit of math, that's equal to this term right here, v squared over r. Now, how you get from here to here is a little longer than I want to have in this video. So I'm going to make another video on where this v squared over r comes from. So for now, I'm just going to say this. When you have a velocity vector changing direction, like is happening here in some sort of circular motion, you are accelerating towards here, the center of curvature. That acceleration has a magnitude of v squared over r. And again, one more time, the direction of that acceleration is towards the center of curvature. And that's what's referred to, again, as a centripetal acceleration, as opposed to what's called a tangential acceleration. Tangential accelerations have to do with changes in speed. And these are the accelerations that in my class that's running on right now, we've been talking about the entire semester. So if you think about an automobile and you think about the controls of the automobile, there are actually 3 acceleration controls. You could apply the gas pedal, the brake, or you can turn the wheel. Right? These two will create tangential accelerations. This one will create a centripetal acceleration, changing the velocity direction of the car. Now, while I'm at it, I'll introduce one more concept here. This force in this picture, the tension in the string here, is what is known as a centripetal force. And I like to define it like this. A centripetal force is defined as any force that causes a centripetal acceleration. Not to be confused with the term centrifugal force. And I'm going to save this for another video, but we'll talk about the end of this. The term centrifugal force is just really kind of a made-up term. There's no such thing as a centrifugal force, and again, I'll save that for another video. Anyway, I hope that this video helps. Have a great day.